My name is Owen Gallen, okay, I'm teacher up at St. Ewan's College. I'm teaching now computer science for 5 years. I'm a past student here at ATU itself. I did level 7 first, then went into level 8. Then I did my teaching degree then down in Queen's in Belfast, okay. So this is my 4th project, so I'm probably trying to bring my experience of the project to use, and to use this, bring it back to the classroom. So what I'm going to go through today is you should all probably be familiar enough with the project and the concepts and topics that's within it. But I'm going to try and go through and show you how to hit each of the requirements that's within the brief, okay? The report and stuff like that, it's up to you, kind of probably look at it. Again, as the project itself is basically the report and the project backs it up. But you can interpret the report yourself, it's simple enough. The requirements to hit is a little bit more challenging, and that's what this is probably going to be based on. And you all know about the whole well-being aspect. Now, the big thing is it uses the microbit, okay? So for this here, we kind of probably need to know what the microbit uses. So requirement number 1 is saying it takes inputs and outputs. So it says the word inputs and outputs plural. So I interpret that as 2 inputs, 2 outputs. So you need 2 of both. You need both and 2 inputs and 2 outputs. So there's the things within your microbit itself. There's all the different parts. You have a little screen, you have buttons, you have processors in the back that takes the accelerometers, like the X and Y axis. You can shake it, you can drop it, it can do all this stuff. So you need to utilize that, okay? That's before you start going on off then and adding in like sensors and stuff like PIR sensors, ultrasonic sensors, crocodile clips, stuff like this I built here. I'll show you a bit in a minute. The microbit itself is more than enough probably to do this project. Okay, you have light, you have temperature, you have all the accelerometers. But if you want, then you can go get heart rate monitors and stuff like that if you really need them. But the microbit itself is probably sufficient to do it. Okay, you have outputs. Main outputs is going to be your sound if you have a V2 and the LED screen. You can connect them up to little LED lights. There's an output. The inputs then is going to be their buttons. You can have pads like this to connect up through crocodile clips. You can have inputs of temperature. You can have inputs of light and stuff like that. Okay, so they're like the inputs you're going to be using. So it's very important that you utilize the full capabilities of the microbit to kind of hit the requirements of the project. Okay, so the task itself is again. You have to identify a situation where computer science can be applied to enhance some aspect of health and well-being in people's lives. Okay? You know yourself from looking at the brief, there's a lot of areas that goes into. It goes into sports, sleep, nutrition, loads of different areas. Okay? And I've seen in my class alone, I've seen lots of different ideas and different projects. But the main thing from that is these are kind of very important. It says top, an embedded system that enhances some aspect of well-being. So it has to enhance, it has to make a difference. And then a computer model that is used to provide insights. So insights into some aspect of well-being. So what I've taken the word insights is I think that's like a research kind of question, a question you come up with in the investigation that you're trying to prove from your project. So let's say we have a sleep monitor that tracks how often you sleep. So your insight is, does 8 hours sleep a night help my mood? So every morning you wake up, you say how you feel. Okay? But you track that night, did they get their 8 hours sleep or not? So you're seeing the insight of, does 8 hours of sleep correlate to being happy or correlate to being sad? Okay? And again, there is no kind of sensor that can track, obviously, being happy or sad. So you're probably going to need to get them some manual input to work that out. Okay? So the task, then, it says you could use these lists, top lists to inspire some ideas. There's some of the ideas from the brief. Sleep, helping others, gratitude, do things you enjoy, connect with others, activities like mindfulness and yoga, regular exercise, do something creative. Okay? Any of these here kind of probably use one of them ideas to hit what is being asked in the brief. If you take one of them, I don't think you can go far wrong from what's being asked, okay? And then obviously utilize the inputs and the outputs and stuff, okay? So, just before we start in, I'm going to do like a live session of showing you how to do the requirements. We need to know what the requirements is first, okay? So there's a lot of jargon in that brief. There's a lot of stuff like that's there and it's just kind of, it's hard to read over it. I do advise you to read through it in detail, these are kind of the main points. This is what it's going to be marked on for the actual code. So you need to do these. So it says create a fully automated embedded system. Okay? So what that means, fully automated, is when it starts, it just shouldn't stop. You can still input stuff within it, but when it starts, it shouldn't stop, okay, until obviously someone comes along and actually stops it, but it shouldn't like crash out or anything. Digital analog inputs, that's your buttons, could be your temperature, could be the light sensor, any inputs into it. You need the word S at the end, plural, you need 2. I presume that is 2. Again, outputs, 2. Okay, so again, it could be sound, could be LED screen, could be lights lighting up here, okay? After you do that, then that information is brought in and stored into a CSV file, essentially. Or you could use Firebase or something if you did that in your school. It needs to store the data. And again, it's very important to validate that. So that means that no data, say if you get a temperature reading of 500, that should be just scrapped out because that's not validated because you can't get 500 degrees, okay? So it's very important to validate the information, okay? Again, a lot of marks went to that last year in the actual marking of the project that I had mentioned a section on validate last year where the students had to validate. And then create an analysis component where you can predict or calculate and inform future decisions. So you need some kind of prediction, okay? So it could be, say if you're taking in light data, are they getting enough light in the day? You can maybe show a live tracker if they're hitting their 100% of vitamin D or something. You could do some model to work that out. And then inform future decisions to see how much, maybe you're hitting the recommended threshold but still feel sad. So you try and work out what threshold they like, and then that informs future decisions that they need to hit this every single day. Okay? So that's the basic. So everyone has to do that, but then if you do an ordinary level, that's as much as you have to do. Okay? For the advanced requirements then, everyone who's doing higher level needs to do this. So create a computer model that basically it can have a data set that you create yourself, a data set you find online, or a data set coming from your microbit data. I would say probably the best one to do that is generate it manually, very much aligned relating to your project, or take the data from your project. Okay? If you get one online, it's going to be hard to fit that in the word count of your report if it's completely different data set. So very much align the data set to your actual project. And I'll show you more about that later. Then you need to have 2 what-if questions. Okay? Does 8 hours sleep a night increase my reaction times, let's say? So you track if they have 8 hours sleep a night in the morning, then they have a little reaction game where they have to react. And you can see when they don't get 8 hours sleep, it's the reaction times down. To get 8 hours sleep, it's the reaction times up. Okay? What if questions as you come up with them. Okay? Then you have to test these what if questions and offer an insight, and then you just graph them. Okay? You visualize them back to the user. So that's kind of all the 6 requirements gone through very quick. And again, what I'm going to do is I'm going to go through this now, what phase and how to hit, hopefully each of them. So basic requirement 1, you're utilizing the microbit. The data capture, you're just basically getting information and storing it in a CSV file. That's the way I'm going to do it. And then an analysis component where you're trying to collect the data and trying to predict something. So does 8 hours sleep a night improve my energy levels? Living in a house with low levels of CO2 improves your mood. Does 5,000 steps a day make you feel better? Does not enough exposure to light make me feel worse? Again, something like if you're doing like a game, or if they're feeling down, they have like some kind of like calming lights or something. Is there a specific mode they always go to? And can you show that mode when they're feeling down? Okay, so you're analyzing what they're doing. Then the advanced requirements, again, come up with the what-if questions. Does exposure to light improve one's mood? Will a minimum of 8 hours sleep improve reaction times? Does drinking water every hour during the day improve concentration? Okay. What hour of the day am I quickest, let's say? Okay. So do your what-if questions. So that's for advanced requirements 1 and 2. And again, you have to do that in a function. So you have to do that in a function. You have to pass the values into a function, and then you have to work that out, and then from that there you get the information back and show it to the user. And I'll show you how to do that. And then again, you have to graph that. So again, you have to visualize. So from what you're picking, you have to visualize it back. and charts or whatever way you want to do it. Okay? So something like that there, where they can actually visually see the information. So what I'm going to do with you today is I'm going to do this now in like a practical setting where I'm going to have timing gates for a runner. So the purpose of my project is I'm going to have these here things. I'll show you these in a minute. It's going to work out. You're going to have one here and one meant to be 100 meters away, but obviously can't do that. 100 meters away. I'm going to use the distance, speed, time formula to run from one gate to the other. And what it does then is it's automatically going to calculate the speed that you went at. So there's your prediction thing. Okay, so it predicts the speed. So I know the distance is 100 meters, and when I step on both of these, it's going to trigger like a stopwatch. So when I step in this one, it's going to stopwatch, it's going to end, and then I can use the speed, distance, time formula to work out the speed. Does that make sense? Okay. What I'm going to do then is the well-being aspect of that is I'm going to look at like training, like if you're not overtraining and stuff. So if you do this more than 20 times in an hour, it should tell you to stop. If you do it more than 100 times a day, it should tell you to stop. So it's to prevent people from being overtrained. They're also getting an analyst component there of getting a good insight that maybe say at 5 o'clock in the evening, they run quicker than let's say 8 o'clock in the morning. Okay? So it's all about it's hitting the health and exercise kind of thing and about their well-being. So we're going to kind of work through it. And the insights, back to that thing, insights, that's what I would put in my investigation there, part of the report. I would just have a site, insights I want to explore. Gains plural, so I have 2 of them. Is there an optimal time for me to run at? Can this system help with my training load? Okay? And that's kind of the stuff I'm trying to explore. Okay? So I'm going to start to set this up for you. And it's going to be on Make Code. And I'll share the code with you in a minute. So before I get started, I'll just show you these. Okay? So you're limited obviously to the microbit, and the microbit is buttons. So to automate the process, this is like a big button really. Tinfoil is really useful. So this is a bit of felt and tinfoil, and on here there's a big pin. You see the big pin coming out there. So what I do is I connect crocodile clip there and it connects to P0 on my microbit. And then I have another bit of tinfoil here and felt around. So what actually happens is the felt is kind of lifted. The felt here, they're not in contact with each other. Okay, because no 2 pieces of tinfoil when they come in conducts electricity. So they're not in contact, but if I push this down, that tinfoil on the top now is in contact with the tinfoil on the bottom. So what it happens to do is, for this to work, is I have it on my microbit here, and I connect up my different parts. So one of them goes to my ground, which is here. So that one there is on my ground. And then the other side then is on the piece of tin foil up here. Okay? So that there now will create a circuit, and I have the other one connected up, where I can push down this and then push this one, and it reads the information. Essentially what it is a big button, okay? And I'll show you the code behind this, okay? So I'm utilizing this gold kind of bar, which is outputs and pins. So if you look here, in this here, I have a thing called P0 pressed. What I'm going to use in this is I'm going to say when I release P0, because a runner has to take off. So when that's released, I'm going to send a message to Python. So we need to create a connection up to Python. So to talk to Python, which you need to do this in Tawny, you need to use a thing called serial, which is USB. Okay, serial stands for USB. You can see there the USB kind of symbol on the thing. So what I can do is I can take the data from my microbit into Python, okay, on Tawny. So for that to work, when my microbit starts up and I download it, I want to transmit the data through the USB, receive the data through the USB at a baud rate of 115/200. That's how quickly the data is transferred. And I want to, anytime it disconnects, you can do a thing that reconnects to USB. Okay? So my code for my microbit is super simple. So when it's released, I'm going to send, it has to be right line, okay? It can't be right string if you're doing this, or right number. I'm just going to say start, okay? Lowercase, start. And again, to hit that other requirement, I'm just going to literally play a little kind of beat to make sure it starts, okay? Because that's an output, okay? And this here thing's an input. So there's one input, one output. Let's hit null output. Let's say that happens. I'm going to tick. Okay? So now, that means now I've started. So when I reach the end, the other one at the end now is connected. So this one here is connected in on this here. You can see my microbit. I know it's probably hard to see for you, some of you. That's P0. P1 is connected here, and they're both connected into ground. Okay? So what I'm going to do is when I press P1, that means I reach the end. So again, right line of end. I can basically do the same thing, duplicate, let's say just slightly different sound, so I know I reach the end, and I'll show another icon of an X. So when I start, just get rid of that. That's all my code. That's as much microbit code as I want. Okay? Now, some of you can go way more detail in microbit. All my main coding is going to be done Python end, because I find that easier. Okay? I find the microbit's capability is really good. It's a good processor and all on it, but I find the microbit would be easier to basically use that information. Okay? So all I do then is I can download that and obviously test to see if it works. So download it, open it, send it to my microbit. And when I'm doing that, I will share this with you. So if anyone wants to take this, there's a little screenshot when you're doing that. Right, so to analyze the information, like Martin will show you something on data logger, I use serial. I think you need to use serial to get the information into Python. It's a critical part of the project that you actually can get the information to Python, because that's where it's going to do the analytics, okay? So let's show, for example, I started that a couple of seconds ago. So let's listen to see, can I hear? So if I end it, you can probably hear that, hopefully. So look. Okay, there is a little beep there. Now, to make 100% sure that that's basically doing that, okay, so I have my inputs here and I have my outputs, okay. I can go to Python, right. So on the other thing, I use this thing called serial, right. So I'm going to use serial here as well. I'm going to import the package called serial, okay. And what I plan to do is I need to find out where my serial port is. So if you open command prompt, there's other ways of doing this. You can search a word called mode in command prompt. Okay, so you have to open up command prompt, search mode. You'll get this thing here for COM port. Okay, you can see mine, there's COM1. I know it's a bit hard to see. So what I need to do is all the information coming from my microbit is coming through this port 1, which is basically port 1 of my computer. And that's how the data is being sent through. So what I want to do is I want to connect to that port. So I can just call this connection. So my connection to my serial is that serial module, dot serial, and my command port is COM1. And remember that thing I mentioned back here of baud rate, the data being transferred, 115200? That is now the baud rate I'm going to use here, 115200. Okay, so that's me now connected up to my microbit. Okay? So what I need to do then next is I need to get that information. Okay? So to get the information, it's going to be inside a while true loop, which is constantly running. Okay? And what I need to do is I need to say the data that I'm going to store it in a variable, is going to be the connection dot read line. So do you remember before over here? Just look up. I've write the line. So I'm writing the line the microbit side. I'm reading the line this side. Okay? So that's now stored in a variable, so I can print that variable. So if I print this now, so if I press run, okay, this will start running down here. And if I just drag this up a bit, so let's say now I press start. Okay, it should be getting me up the data. Hold on, now this might be the wrong COM port. COM8, it's just changed. Sometimes that does happen. Let's change that to COM8. Rerun it. Press start. Okay, see there, I'm getting my information. The runner's going, the runner's going, the runner's going. The runner, they've stopped. They've ended. Okay? Now, the thing about this is when the data goes into the microbit, it's going through the USB. You see the B dash and the RN and stuff. That data is encoded, so it can't be like kind of tried to basically encrypt it. So we need to decrypt that, basically. So we need to decode it. So the first thing you need to do is get rid of them /r's and /n's, is decode the information. And then you need to strip it because there's a pile of white space here. So the word .strip removes the white space. So if I rerun that here, and I go now, press my start, there's got rid of that, press my end, bang, I have start and end. Yeah? Does everyone make sense of that? Okay? So I have now the information coming in. So I'm going to start now to build my thing. So I'm going to say 100-meter time trial. So let's make it like kind of like a game. Okay? So 100-meter time trial. So what I'm doing is when this data is coming in, I'm reading it. So I always start. How do I start? It sends a message of the word start. So while that data is coming in does not equal start, for example, if I hit the end one by mistake, then what I want to do is I want to just keep reading the information. So it's like a loop to make sure you put in the correct thing. So when you start, you have to start. Okay? So we cannot start until I get that message start. Okay? So let's just make sure that's the case. So now, what I do is when I run this again, if I press the end one first, I should get nothing. Okay? But if I press the start one now, it should bring me into, sorry, it should bring me into this started. Just make sure that data is coming in. Sorry. Just run the wrong one. So see there now, it says I started, but if I try to end, it doesn't say the word started. Okay, so it'll only start when the data coming in equals started. Okay, so just to make this easier for me, I'm going to take this off because you can get the idea of that concept. I don't want to be leaning over the whole time. I'm just going to slightly change my code for testing purposes, and you should probably do this too in yours. So when I press A this time now, I'm just going to use the buttons, and I can change it back to that at the end. So when I press A, we're going to start, just for my sake, so I don't have to go over and back. When I press B, I'm going to end. Okay? And that's a good thing for you to do too if you don't need to constantly be pressing and connecting up all that there parts every day you come into class. You can just simplify it and then add that. You know that works, so I can just connect that up again at the end. Okay? So there's my information now coming in. So that starts. So when that starts, I want to start to track how long obviously I get from the start to the end. Does that make sense? Okay. So to track any time, I need to take in this module called datetime. Okay. And I just import it. It's built into Python, so you don't need to install it or anything. It's just called datetime. Right? So now when I start, that means here now I've started. So what I can do is when I start, I can work out basically when did this information start. Okay? So what I'm going to do is I'm going to create a variable called start, and I'm going to take a time of that now. Okay? Let me just show you what this means. I can get rid of this one. Right. So now on this here, I've put it onto my code so it's easier. Right. So, sorry, there's a lot of moving parts to this project, so there's a bit it's going to take. So see now when I press A and B, okay, what it does, it takes a timestamp. Okay? So I know exactly when it started. Okay? So what I'm going to do then is, obviously when it starts, I now need to wait to get the information again and wait till that information is ended. So I can say while data coming in now, so this data here, while that does not equal the end one, I want to essentially get that information. So this basically this goes into a loop that it just reads this over and over again until they type an end. So I've started, I can't go to end before it starts, so it can't put in any information until they put in start, because this goes into a loop. Until you enter start, it starts. Then it does start, it takes the time of when it starts, and now it goes into a loop of this constantly goes and goes and goes until we end. Okay? So what we want to do is then, when it does get the thing end, we're just going to say finished. Here. And again, we're going to take a timestamp of when it finished. So I'm just going to have the word end equals that time. See here? And I can just print that back. So I can print end. So now what should happen with this bit of code is I'll start, the thing's running, you can hear it beep. Now when I press B, it should say I end, and it goes again. So you can see there was what, 6 seconds? Yeah? Started again, 41, stop it a wee bit quicker. 41:08, took 3 seconds that time. Does that make sense? Yeah? So we're starting now to get the information. So what we need to do now is we have the start time, we have the end time. We need to see how long that took. So I'm going to say taken equals end, because end's bigger, because it's after, if you think. End minus the start time. Okay? And what I can do then is that stores it as a thing here. Let me just show you. It stores it as a date stamp. Okay? But we can get out. So if I run that again, you can see taken is like this. Okay? It's that told me it took like 70 milliseconds, basically. I can get what is the total seconds of that and get rid of the hours and stuff and the days from that. So I can say total underscore seconds. It's a function inside it. So if I run that again now, it should only show me the number of seconds. So I started at 11:42:14. I ended at 19. So that took me 4.283 seconds. Okay? So you can see now, I'm starting to get information. Press B again, took me 3.4 seconds. So if I start as a runner here, and I get to there, it's going to work out the time. Or the time. Does that make sense? Right. So that's basically utilizing the information. So what we need to do then is we need to work out the speed. So the speed is your speed distance time formula. Okay? So I know the distance is 100 meters because it's a 100-meter time trial. And then what I'm going to do is I'm going to take basically the seconds it takes. I'm going to put that in there. So what I can do now is I can tell them, print, your speed is the speed speed. And I'll just say, because I know it's km per hour, and I'll close that. Now it should start to work out how long it takes. So let's say I'm manually doing it. So if I start there now, they've started running. We did Usain Bolt at 9 seconds. So let's hope we can get close to his. Stop at 9.37. So he was going 10 kilometers per hour. So that's hitting, what requirements is that hitting? So they're brave enough to speak. That's hitting basic requirement 3, because you're starting to kind of model the information. You're taking in the time, and then you're modeling that information to work out the speed. Okay? Anyone any questions on that? Does it make sense? Yeah? Right. So, the next kind of thing now is to do, if we look back kind of at the thing here. To do this, we need to validate it now and store the information. Okay? So, we did this, we've calculated or predicted certain information. We haven't informed future decisions yet. We haven't did that. But before we do, to inform future decisions, you need like historical data. You need a build-up of information. Okay? So what we're going to do is we're going to start to validate and store the information. And I would say the easiest way to do this would be to go to Excel. You can create an Excel sheet if you want on Python, but I would just go straight to Excel, okay? And I would just make it. So the information I'm going to save is I'm going to save the date, the time, let's say the day, the very first row. These are going to be the columns, and Python's going to send it into it then. The hour, the taken, so that's how many seconds it took, and let's say the speed. Okay, not that much information. You can add in a lot more than that. That's just what I'm going to do for today. So the main thing you do from this is if you're doing this in Python, to read the file, you need to save it to the same place as your Python folder or your Python file is saved. So I haven't actually saved my Python file. So what I'm going to do for both of these is I'm going to save this here in my download folder. So I'm just going to call it ATU. Okay. And my Excel file, I'm going to save to the same place. So I'm just going to call it, let's say, data. I'll just call it data. Okay. So now, if I open up my downloads folder, you'll see I have data in ATU in the one place, my Python file and my Excel file. That's really important for us. You can't open your Excel file unless it's in Python. Now, the only thing I probably haven't done that, when I saved it as a workbook. Okay, don't save it as a workbook. It needs to be CSV, .csv down here. So I just saved that again. Okay, so make sure it's a .csv and not a workbook. So just make sure you do that. Okay, so let's just say I'll get rid of that. It's just in case it causes issues. No, I'll just move it to music or something. Okay, now that they're in the one place, I can start to use that file to start to read information. Now, you can't write any information if this is opened. You can't write information when this is opened. There's a thing in Excel and Python, they don't interact with each other well. So what I need to do is I need to close this. I have a thing called Visual Studio Code open. This is some historical data. If you have it, if you want to see the data coming in live, you can use this. So if I open that file from before, it's in here called data. Okay, you can see it there. That will allow me now to see live data coming in. So I have them columns. So let's open up Tawny again. Okay, so in Tawny now, what I want to do is I want to start reading the information. Okay, so for this, it needs to be inside my loop. So what I want to do is I want to open my file called data.csv. Okay, CSV. And what I want to do with it is I want to read the information from it. So you need to say to it what you want to do. No, I want to append information to it. I want to add information. Okay? So then what I'm going to do is I'm going to call it file here. And now that gives me an option. So what I want to do is every single time I want to write the information. File.write. Okay? Now, if you look at my file, if I open up this here, no, it's a bit more awkward. I have the date, I have the time, I have the day, I have the hour, I have the speed you went, or the seconds taken and the speed. So there's a thing online called Shrift Time for the date time module. So if you search Shrift Time Python, okay, it's like a cheat kind of code to get back the day of the week that it was, the hour of the day, whatever. Okay, you can see it in here. You can go down. You can basically copy and paste it. Okay, so if you scroll down to the bottom of this, that gives you the stuff. So the first thing I'm looking for is basically the time and the date. So a small x and a big X gives me the time and date. So I'm just going to have above this, when this happens, so the end time, I'm going to work out the date is going to be the end time, and I'm going to just say shrift, S-T-R-F-T, shrift time, percentage, big X is for date. So when I have date done now, it's just literally copy and paste this. So that's date. The one below is time. It's a small x. I'll show you these in a minute before we add it in. So I'm going to say end, or time. Day, I need to go back and read this again. Let's close the ad. So the day of the week, I'm going to store as a weekday as a decimal. So I'm just going to say lowercase w. So lowercase w for day. And I need one more, which is hour, isn't it? My thing. Yeah, the hour of the week. Because it's very important we get the hour, because we're going to see what hour of the week do we run the quickest. Okay? Is there a day, or is there an hour per week that we run the quickest? So again, in the hour, it is a big H. Okay, so I'm just using that page. So if I copy and paste that again, big H now is the hour. So let me just show you what that means, very simply. So now I want to write this information. So what I'm going to do is I'm going to say the first thing in my list is I need to go to a new line. So it's very important you go to a new line on this. Okay. Then when I go to a new line, I'm writing the date here. And how the CSV file works is there's comma separated values. That's what it stands for. So there's a comma between each of them for each column. Okay. Then the second one I'm going to write is the time here plus comma. The third thing I'm going to write is the day of the week. The day of the week. Again, plus comma plus. The fourth thing is the hour of the time we took. Again, comma between. The last two things then is these all need to be in strings too, so you need to convert to correct data type. You need to see how long it took them to do it, so taken.total seconds, total underscore seconds, so work out how long it take to do. And the last thing is a plus, comma, and I want to get the string of the speed. Like this. Okay? So there's all my information now. So if I rerun this, okay, so I'm running this now, I'll open my spreadsheet, and I press A to start it, and I press B to end it. This should have an error somewhere. It's telling me float. str. Where is the error? /n plus. So there is a lot to this. Sorry, I didn't close this bracket. It's my fault. And okay, sorry, that's my fault. So again, press A, press B, 1.3 seconds. Press A, press B. There's my time. So that information now is starting to be saved. So when I'm running it, that information is going to be there historically. That's never going to delete. Okay? So I'm getting in there. If you can, sorry, if I can make this slightly bigger. You know what, I'll open the Excel sheet again. So you can see in here, that information is now saved. Okay? I can start to analyze that. So the reason I have day and number and hour is because there's a part of the what if questions that ask you to use different data types. So instead of using day of the week, I'm going to use a data type to search for a number. Zeros, Monday, Sunday, 7. Okay? Hour of the week's there, time taken, and the speed. So what I could ask them to do is for the what if questions, you can search for over a certain amount of speed or something. Okay? Does that make sense? The code for that is you just create the CSV file yourself. You can even just go in and delete this if you want, then if there's any problems. You have that saved. And then on the Python side, you're just basically opening that CSV file. You're writing the information of the date, time, day, hour, the speed, and the time you took to do it. And every time it's going, you need this /n, it goes to a new line, and it writes that information. Does that make sense? Okay? So that's now, every time I add that, it be added in here. I can add information. Easy. Okay? You can see there, every time I'm running this, that stuff's saved. Of live times, live dates and stuff. Right. So, basically then, when you have this now, I suppose the next part is to do a future analyst kind of thing. So what I'm going to do for the future analyst, and I had a few things planned, is I'm just going to compare. Mine would be like for a club, like an athletic club coach or something. I'm just going to compare what your speed is when you run compared to the average of the club. Okay? So are you quicker than the average or are you slower than average? And I'll give you a goal to work towards. Okay? So to do this, I use a thing called Pandas, which is a file reader kind of thing for data analytics. So I need to import it at the top. Okay? So I import the Pandas package, and then with it, I'm going to read a file. So Pandas has to open that file, read_CSV, and what the file it's reading is the same file that I just wrote to, .csv. So now, what I can do with it is I can print that at the end every time. So you'll actually get that file. So if I run this now in Python, and I go down here to show you, because it's quite a big thing. So if I press A and B, you can see there now, there's all my information in Python. Okay? You can see all the historical data. So what I want to do is I want to go, let's say, to the taken time. Okay? So I'm going to this column here, and I'm getting all of the takens. So I'm going to mash all them together, and I'm going to get the average of that. And I'm going to say, is what I run greater than the average? Am I quicker than the rest of the club, or am I slower than the rest of the club? Okay? So to do that, it's straight enough forward. So to get the average is you go to the column taken, so it's one bracket taken, and you say the word .mean. Okay? So that will show me the average. Okay? So I can say mean, and I'll say the word seconds is club average, and speed is, again, comma, df, and I go to the speed column, and I close that, and I say .mean. So you can see now, instead of it showing the whole data set, so after every run, you get to see the average. So the average is 8.7 seconds, and the speed is 130. Let's go again. So if I leave it a wee bit longer, does the average slightly come down? It came down slightly. Okay? So that's the overall average. So what we're going to do is we're going to take this overall average here, and we're basically going to say if if our time here, if our time that we took is less than the average, so is less than the average, we're going to say quicker. We're just going to say print quicker than club average. And if we're slower, means else, we'll say keep working on it instead of giving a, because it's a well-being program. So we're just going to say keep going. Okay? So if I run that now, and I press A and B really quickly, you see you're quicker than the club average, because your speed's quicker. But if I go, say, someone old in the club, really slow, and I press B, they actually still come in quicker. They should come in slower. I'll leave it for a while. See, it says keep going, because their speed was below the average. Does that make sense? Right. So that's kind of, again, that's doing a model. That's not really informing future decisions. I don't think. That's not really informing the future decisions. What I would like to do for the future decisions is I'm going to use that R column. And what I'm going to say to the runners, if you've did, let's say, 20 runs in the hour, it should come up with a message, you should stop, increased risk of injury. That's informing future decisions. Okay? Or for the day, I could track the date, and I could see if they've run 100 times in that date, it should just say stop. You're going to increase, you're increasing your likelihood of injury. You're not going to get any benefit of doing any more runs. Does that make sense? Okay. So that's what I feel would be informing the future decisions, and that's around well-being too, because you're trying to promote that they don't overtrain. So we'll look at doing something like that. Okay. So what we need to do for this one is we need to get the R and only the R's. Okay. So what I'm going to do is I'm going to create a new DF, which DF stands for data frame. So that's a new Excel, basically creates a subset of a CSV file on that R. So I'm going to say where that DF and the original DF and getting the location of where the R, along the R column, that equals the R we're in now. Because up here, we have got the R we're in currently. If we get all the R's that equals the R we're in currently stored in this thing. So that only gets, now it's not really going to work too well, but I'll show you just, I might link into yesterday's data set when I was working on it. So that gets all of the previous R's work. Okay? So what we're basically going to say is it has a length. So if the length of that R is greater than, let's say, we'll put it, well, how many rows do we have in that? 16. So say if we go over 20, we'll say print stop training. We'll just say stop, and you could say like stop training, increased risk of injury. Okay? And then, otherwise, they've obviously haven't hit it yet. We can just say, we can tell them how many runs they've did. Run, and then we'll just say the length of it again. So I can see how many runs I've did. Length of DFR. So now you're starting to inform future decisions. Okay? So, again, it's using all this information. So if I start my time trial, and I end it, okay, it should get me the information. It's saying run 0, right? Why it's saying run 0 is in here, the R is stored as an integer, okay? It's stored as an integer. So what we need to do is when we open this file, we need to store the R as a string, okay? So it does get quite complicated. So up here, when we open this file, I'm going to tell this that the data type of the R column, so the R column, I want to be a string. And it just needs to be a string for some reason for pandas. It doesn't work if it's an int. And I know that doesn't really make sense when you're so used to using it in class between strings and ints. So if I rerun that now, and I start, so you can see that's run 2, because we're in a new error. Run 3, so let's say I go for 5, because it's just turned 12:03, so we're in a new error. The old data is just forgot about. Okay, just rerun it. And we start again, we end, run 4, start again, and run 5. So now I've hit my limit. So the next one, it should just say stop training, increased risk of injury. Now, there's obviously no way to make them stop, but it's giving them that decision. So you're helping them for the future that they're going to be reducing the chances of pulling a muscle or something when they're doing a run. Okay? So that's now informing the future decisions. Okay, is that clear enough? Okay, I know that's quite complicated. Pandas is a great tool. I don't know if you did it in class or anything. The L2, a lot of the L2s around. Pandas is a thing where you can go to a CSV file, pull out columns, get averages, get maximums, get minimums. You can do data analytics on projects really, really quickly. Okay, so the last kind of thing I suppose to show you now is the what ifs. Okay, we have our data. It's to show you the what ifs. So what I'm going to do for the what ifs is I'm going to just put it up towards the top because it needs to be inside a function. I would say have 2 modes. I'd say ask them when they come in, 1 for automation, 2 for your what ifs. When they go into 1, that just runs there automatically. That just starts in. So what I'm going to do is I'm going to have a function called over limit. So I want to see, my what if questions is going to be basically, is there an hour of the day that I'm kind of quicker than anything else? Okay. So for this, it asks for 3 parameters passed a function for advanced requirement. So the 3 things I'm going to pass is, I'm going to pass the limit, the option they choose, and a thing called over, under. Okay, so that's kind of my function set up. Right, so what I'm going to do before I start passing stuff to the function, I'm going to ask them basically to do this. Okay, so I'm going to say, are all the numbers that are over, under a limit? So I'm going to say over/under limit, just so they know. So what they're going to do is they're going to choose here that they want to go over or under, let's say speed, and then they say, let's say they go under 2 seconds. It'll show them back all the times under 2 seconds. Let's say they go time taken over 5 seconds. It will show all the people that's over 5 seconds. And it will show you back then the hours of the day that you're most over 5 seconds. So is there a time of the day when you're slower than other times, obviously? Okay? So what we need to do for this is we need to get, do they want to do speed or time? So we're going to ask them, just called op1 equals input. And again, you should do validation on this that it can't have anything else, but I don't really have time to show you that. That'll be inside a while loop. So I'm going to just say speed or time. Then my option 2 is going to be over or under. Op2 equals input over under this. Okay. And option 3 is going to be my limit. So you have to choose like a thing. And it's very important it asks for 2 data types. So my data type is going to be an int input, because that's a string, or a number. So what I'm going to do is I'm going to, probably better to use, well, just use int. You could use float there too. I'm going to just say enter limit. Now, if you wanted to get hit, make sure you're hitting the 3 data types. You could see for speed and time and over and under, you could use true and false as well. But it's not really applicable. Okay. So what we want to do then is when they enter them 3 things, you should add validation. I'm passing it. I'm going to say data equals call the over limit function. So this is calling the function. And what I'm doing is the limit is option 3. So I need to say pass in option 3 first. Then the option that I pick, so that's either speed or time, that's option 1. And then over under is option 2. So they go up, whatever I input here, it takes it. So whatever I input in these 3, it calls the function up here of the 3 parameters, the 3 values, and that sets them 3 values here to use. Does that make sense? These all covered functions. Functions is very important. You do this for this advanced requirement 1 and 2. You need to do it with a function. If you don't understand functions, there's loads of YouTube videos and stuff out there. You can learn it in 10 minutes. Okay? So when we now pass to that function, we want to start doing something with that information. Okay? So let me just get this up to make sure it's correct. So the first thing I need to do is I need to read the file for me. So I need to read that file of the information, CSV, and what I can say is data, it's called data.csv. So I read that information in, okay? So what I'm going to do is I'm going to say I have 2 options for over under. So I'm going to say if the over under equals the word under, that means we're going under the limit, okay? Anything else will mean we're going over the limit. Simple enough. So then what I'm going to do is when that happens, I'm going to create a new data frame called df unique, let's say. And what it's going to do is it's going to go to the original data frame, and it's going to go to the location of the option of the column. So this here, you're choosing, are you going to the speed column, or are you going to the taken column? This should be taken, sorry, taken. So am I going to the speed column, or am I going to the taken column? So that's op 1, okay? So I'm going to that option that they put in, and what I'm doing then is, because I'm going under the limit that they passed. See this limit? And that's it, okay? So then I copy that from there into the else, so if they're going over, so I say greater than the limit. So that creates now the data frame of them limits. For a function, what you want to do then is return back the value. So I'm returning back df unique, and now if I print this, so if I print data here, this is hitting advanced requirement 2 and 3, or sorry, 1 and 2. So now it's going to ask me, it's going to the file, it's going to ask me here. Sorry, just let me lift this to show you. Very hard to see this. Okay. So it's nothing to do with the microbit data now. So it's asked me, do I want to go to speed or do I want to go to taken? So let's say I put in the speed column. I want to go to speed, and I want to say any speed that is over the word over. Let's say, I'll say in here, what's the highest speed? We'll say anything over 150. I want to get any speed that's over 150. So you can see there now, that is returned to me all of the speeds that is over 150. You can see there it skipped some rows. So line 5, line 9, 10 has all been skipped because it's returning me them rows without that. Okay? So you're asking the what if question. So I'm looking there, I'm finding out that there's the times there I'm going really, really quick. Okay? So that's probably, is there something in that where that or I'm going really, really quick? Okay? There's no way to prove this. It's just you're trying to answer the what if questions. So the last thing before I go, okay, is I want to show you how to visualize that. Is PLC, right? So to visualize this information then is really, really important to basically give them an idea of how quickly they're going, okay? So it's just the last thing to visualize, and then that's me. So in here we have the data now. So what I can do with the data is I can basically say, I'm going to plot, is there an hour and a speed? Is there a correlation between the hour and the speed? Okay. So what I'm going to do is going to create a bar chart. quickly, of the data, 2 seconds, of the hour. So this is advanced requirement 3. And with that, I'm going to say the data of this data of the option that they've chose, op1. Okay, so that's the one they've chose. And then what I'm going to do is I'm just going to say plt.show. So I'm creating a bar chart of that. So now whenever I run this in, okay, it's going to create a bar chart. It's going to visualize the information they're looking for. So if I go to speed and I want to go over, the word over, let's say 150 again. PLT matplotlib.pyplot, sorry. 2 seconds. Sorry, you just have to enter this all in again. So say speed over, let's say 150. So now I'm starting to get a data that here is basically being visualized. Now it's not being visualized very, very well, but I'm starting to get it back. So what you need to do is, for the third part, that's really important. Now the only thing I can do here, and hopefully this might fix the way this displays, is I can say that's a string. So now we've gone from getting the information from the microbits into Python, storing it in the file, doing the what if questions, and then lastly, let's say we'll go taken this time. We'll say let's see the speeds it's taken over 2 seconds. There you can see there. So I can see then visually, I can see that at 11 o'clock I was a lot slower than I was at 12. Okay? So if you had, I have only 2 hours, I have only a sample data of 2 hours, but if you had that over a full day, it will visualize every hour of when you're quickest and slowest, so you can visually see the information. And hopefully now that has given you a better idea. You can see, I probably think this is one of the hardest projects that's been asked when I got into doing this and going through it. There's a lot of moving parts. You have to get a microbit, you have to get the inputs, you have to get the outputs, you have to store that information going through serial into your thing. You have to then model that information. You have to take the information that's being modeled in the CSV file to then work out your what if questions, and then you have to visualize that information. So realistically, it's actually, do you know them else you do, the applied learning tasks? It's 3 of them mashed together. Okay? So I hope that it may be useful to use. And that's me done. If any questions, fire away. And I hope you may take something from that. Okay? So thanks for listening, and I'll pass you on then to Martin.